So do I need all this? No. I mean, I do need to look at it, but what's the key part here? This is loading the data. So I have an X and a Y that are coming in from somewhere. In this case, it's coming in from the load iris function. Your X and Y are likely going to come from you splitting up your data frame. You're not going to call the load iris. Then you build estimators. In this case, I see a random forest classifier estimator, and I see another estimator. And the key here is I have two estimators. Notice it's a list with a dictionary inside the list. And the key value, it's a tuple. Thank you. Not a dictionary. The first argument is the name, and the second argument is whatever the actual estimator. And then right here, what has happened is I have something called RF, forest classifier, and I have something called SVR, support vector classifier. And then I'm going to create my final decider, which will be this logistic regression classifier. So the arguments here are the estimators that are being used as input, which are these people up here. And then the final estimator makes the final decision. This final estimator doesn't have to have a name. If you look here, they just created a new logistic regression object. They didn't give it a name. What's happening is this random forest is making its decision and feeding into the logistic regression, and support vector classifier is making its decision and feeding information in. One thing that's important to know here is that unless you specify otherwise, this logistic regression model is also looking at the data on its own. So essentially what's happening is these predictions are just being added like columns to the data that the logistic regression machine can consider. It's not only looking at their predictions, it's looking at their predictions along with the original data that their predictions were based on. From there, it's exactly the same syntax: train, test, split, and call your classifier. And because we haven't talked about some of these in a while, I'm going to build one of these as a supplement to my spam prediction. So I already have a random forest predictor that's doing pretty well. So I have this, let's try to predict spam. And what kind of models would you like to use in our stacking classifier? Okay, we're going to have a max depth of 15. That's great. And we can call this UTC. There's nothing that says you can't have other decision trees, but let's not do another decision tree. What's another model that we could use? Random forest. Okay. And how many classifiers do you want to have in the random forest? 7. All right, we're going to do a random forest of 7 classifiers. And let's throw in also logistic regression. I'm not going to throw in any, and let's have all of these be fed into another decision tree. So I'm going to have another decision tree. So to do this, I've already got my data built here. I'm going to, at the beginning, import the things I'll need. That is good practice. So import a random forest classifier and from sklearn ensemble. These are called ensemble methods. Copy, paste, change, perfectly fine. All this estimators and copy paste it. And see right away the downside of copy, paste, change is it brought in all these dots. I didn't be aware of that. And I also have to be sure that whatever I copy pasted is what I wanted. I'm not interested in having a pipeline with a standard scalar and a linear SVC. I'm interested in having a decision tree with a max depth of 15. A copy paste might have worked better. I'm going to have a random forest classifier called, we decided it should have 7 classifiers. LR for logistic regression. I'm not going to try to adjust any hyperparameters. I've done something wrong with the syntax here. So there are two parentheses that need to happen here. The first is like, this is another reason I think it's ridiculous to have a tuple instead of a dictionary, but this is a tuple, so it'll have outside parentheses, and the name of the classifier will be separated from the type of classifier that it actually is by a comma. Then I'm actually building my stacking classifier model. CLF will be a stacking classifier. Those of you who are good with computer science will understand what's happening. The estimators equals estimators. To make it clear to those of us who are new, I'm going to use my estimators as the name of the variable. Rest I need. Final estimator. Oh no, let's say max depth equals 20. Can put line breaks, commas for readability. I think that's kind of nice, but this syntax, if you have exactly what I have here, should be sufficient to create a stacking classifier called CLF, whose stacked estimators are the 3 estimators that we defined up here: DTC, RFC, and L. And then just like any other classifier, we now fit it to the training data on stacking underscore classifier. It's supposed to be stacking classifier. Oh yes, the import statements. Yeah. So even though It's better to put your import statements at the very beginning of a doc. I'm teaching live coding. I usually put them close to where they're used so you can see them all, everything all. It's kind of a trade-off. You should really put them all at